Okay. So this is Unit 3 exemplar. This is problem 3. We're starting with the rate of decay equation. Derive the number of radioactive isotopes present at time n of t. So the radioactive rate of decay equation, dn of t equals negative lambda n. So we want to find n of t, so we want to isolate n. So we got dn of n equals negative lambda dt. So now we want to integrate this so that we can get just n and just some term in the function of time. So then solving this side, we get natural log of n equals negative lambda t plus c, where this is some integration constant. So we want only n, so we take n becomes e to the negative lambda t plus c. And then we can say that is equal to e to the c plus e to the negative lambda t. And then since at t equals 0, we know n of 0 would be n naught, which is just the original term, whatever it starts with. So then our final equation for n of t is n naught e to the negative lambda t. And that makes sense because it starts with original sample size with our n naught, and it's exponentially decaying. So now we want to use this result to derive the mean lifetime of a radioactive isotope in terms of its decay constant. So we have the equation T equals integral 0 to infinity So we know how to do this one. So we'll start with that. And that equals negative e to the negative lambda t. Lambda, I'm going to solve that over the limits, which equals 0 plus 1 over lambda. So we're left with 1 over lambda on the bottom. And then it's now going to the numerator. By rule, we know that we can take the partial in terms of lambda and then we can just take out that t. It's x e to the negative x, so we can use that partial derivative. So then we're basically just left with, we can do this, and since we already know what that one is, say here, so then the partial derivative in terms of lambda of 1 over lambda is just 1 over lambda squared. So when we plug that back into the equation, the 1 over lambda squared over 1 over lambda simplify that fraction. It's lambda over lambda squared. So 1 over lambda is the average lifetime of our radioactive isotope. And this is making sense because lambda is the decay constant of the material, so how fast it's decaying. And so its lifetime would obviously depend on that value. So yeah, thank you.